Okay, everybody, we're gonna get started today. Just a couple of announcements. There are all the test cases available for rock, paper, scissors now on Codathon. So I have done a regrade all, so it tested your most recent submission again. If you're not passing everything, make sure to double check that. I should have all of the test cases for the jump game out tonight, and then your next homework assignment will be available no later than Monday, next Monday, a week from today. I think that's it in terms of announcements. Any questions before we get started today? Yeah. So if you're getting this error that says you've used more than 256 megabytes worth of memory, it's not that your program's actually using too much memory. The real error is that you have a segmentation fault in your program. A segmentation fault is accessing memory that doesn't belong to your program. The most likely cause for this is going out of bounds on an array access. For right now, that's your most common reason for this occurring. It could be something different, but that's most likely what's happening. Yes? I will give you solutions after the assignment is due. Well, I mean, I'll give you solutions for like the current homework after it's due. Were you asking about something else? No. It got bumped up to like this week, right? So it's due this Friday. So, yeah, there will be solutions after that. Anything else? Okay, let's get into things. So last time I said I was going to look up how do you import just a single symbol from a namespace. So it's using some namespace : symbol. So if you said using std : find, you can now just say find and be able to use it no error. Or you wouldn't have to keep saying std : find all the time. Or if you said using std : string, you could just say string instead of having to say std : string all the time. Brings in only a single symbol. If you wanted to bring in all the symbols from a namespace, again, it's using namespace, whatever that namespace is. Again, generally this is like discouraged because the whole point of the namespaces is to prevent name collisions. And the more times you keep doing something like this, importing more symbols into your current namespace, the more likely there's going to be a name collision and there's going to be problems. So recommendation is to not do that. But it exists. We also left off last time about doing split. So I finished doing split the other day. Here is split. So again, we were going to make a vector of strings as a return result. So I have my strings. There's this new type over here. It's called size t. It's probably an unsigned long integer, so it's a really big amount of space. I had to use this to make sure that pause could actually be equal to end pause. If I didn't, my variable wasn't actually big enough. So I make my position of my substring is going to start at index 0. Then I attempt to find the string that contains the first occurrence of my delimiter inside my string. That's where I'm going to start at. And I want to keep going until I've reached the end of the string while there are no more of those delimiters that keep showing up. The way that I'm going to get to my next delimiter is its pause is equal to string.find. Again, I'm trying to find the delimiter, but I want to start at pause plus the delimiter size. Start after that delimiter. So again, after I find that occurrence of that substring, that's where I want to cut my string off, and I want to copy everything up to and before that point. So I make a new string, and I find a substring from the original, starting at substring start, and its length is pause minus the substring start. That's how many characters are going to be in there that I want to copy over. Then my next substring, where it's going to start at, is at pause plus 1. 1 character after the end of that delimiter. Then what I do is if substring start is less than string.size, so if the substring is still somewhere between where I am right now and the end of the string, I haven't copied up to that space, copy it over. This is what happens here. So to see this in play, right, I have this string plus A plus B plus C plus plus D plus, which I'll get rid of this one for right now. And again, we're splitting on the pluses. So one thing that I want to show you is the debugger. And the way that you can set breakpoints is by clicking to the left of a line inside of your program. The breakpoints are where you want your program to pause at while it's executing so that you can examine its state, so that you can see what's going on. So if you want to see like the evaluation of a particular expression, you can type that in there, and I'll show you that in a second. So you can say like my map at something, and it will show you the value that's there. Yeah. If its size was 0, that would mean like no elements are in it, but I'll show you how to like inspect more things in 1 minute. So let's say I want to stop here inside of my program on this line right here where I go to add it to the back. So to run the debugger, you press the debug button. If you're on Windows, this other little window is probably going to pop up in a second for where you can actually type in your input if any input needs to be given, and it will also show the output up here. If you're not in Windows, there will be another little tab down here, which doesn't appear on mine. Actually, it is up here, called Console, and you can type your input in here as well. Again, like if your program's looking for input, like, hey, do you want to play rock, paper, scissors, and you need to type rock? You would either type it over here inside this screen, or you would type it inside the console. So we can see that right now, the position, so pause right now is equal to 0. I don't think you can see that very well, but you can see it up here. So pause is 0 because our first index of our first occurrence of that delimiter, again, the plus sign appears at index 0, right? Does that make sense? So I'm going to go add the elements from the string starting at 0 up to, but not including 0 minus 0, which is 0. So I'm not actually going to copy any characters. So I'm going to end up with the empty string. Again, if you want to see the evaluation of some different expression, you can go over here and click this plus sign, and you can add in this new expression. So if I want to see like pause minus substring start, I can type that in there, and it's going to show me the result of that evaluation. I know it'd be nice to be bigger, but I can't make it bigger down here. So it's 0. And you can also see the other things, like pause is 0, and substring start is also 0. So 0 minus 0 is 0. We'll copy over 0 characters. And then my substring start is going to be equal to position plus 1. And then pause is equal to find the next delimiter, which is at index 0, 1, 2, 3. Right? And our delimiter size was 1. So we're actually going to start searching at this index right here. Starting searching at index 1 to the end, or for the next plus, which we should find over here at index, is again 0, 1, 2, 3. If we step over, we'll see that that indeed is what's happened. We're not at the end. I should talk about some of these buttons over here. So there's step over, step into, and step out of. Step over and step into both do the current line of code that you're on, but step over, if you're on a function call, does that entire function. Step into will go into that function call, and it will pause at the beginning of that function call to allow you to inspect what's happening inside that function. Step over completes the function that you're in, and it will return back to where you were called from. So if I wanted to complete this entire function right now, I could just press step out of, and I'll go back to where I was called. This guy over here, resume, he will bring you to the next breakpoint that your program would encounter. So if you want to skip to the next breakpoint that you have set, you press resume. What will happen right now if I press resume is because we pick up execution again after line 80, and we wrap back around up to lines 76 doing the for loop again. My next breakpoint would actually happen again at line 80, because that's the next breakpoint I would encounter in my execution. Are there any questions about step out of, step into, step over, or resume? Okay. You guys all used a debugger before? Okay, so if you haven't used a debugger, you're really going to want to get some practice with this. Because the only way to know what's going wrong with your program is to actually run your program and have it display what's happening, right? Because we have this, intuition of this expectation of what we want to happen, and we have what is happening. And if we've screwed up, we know that those things are out of line somewhere. But I don't know if your first instinct, like me, is when my program doesn't work, is just to stare at it really hard. You're like, why aren't you working? Right? I did the right thing. I did the 100% correct. Why aren't you doing the right thing? It must be your fault, program, not mine. I didn't make any mistakes. Right? And so we just look at it really hard. But that's not going to be really, really helpful for finding our bugs. Because, again, we believe our code is correct. We didn't put down stuff we thought was wrong. Right? So finding our error is going to be really hard. So we need something to point out to us what's going wrong. We need the debugger to show us what's actually happening. And when we find our deviation where things are going incorrect, right, then we can pick up and realize, oh, well, that's actually what is happening, and then I can go and fix it. But again, like what's actually wrong is you're going to have to figure that out yourself. So the next position that we found, our next plus sign was at plus, right? And so we create this new string, and this substring start, if we do pause minus substring start, that's 2 characters long, right? Which would be the A and the space, which makes sense as the next thing that we should be getting as our next substring. And then we increase our substring start to start at after that plus sign. So start at this space right over here. You can also click on some of these like drop downs and you can see the values that are being put in here. So you can see my first element is the empty string. Then I have a space. If I press resume, it's going to bring me right back to that breakpoint and I can see things happening again. So after I click step over, you can see that, oh, it's added that new substring, B, in here. Then if we go again, and maybe I want to move my breakpoint down to here, we get the C, then we get the empty string again, and then I think we get another, oops. Oh, one other useful thing that you can see over here is this is the call stack, and it shows you where calls were called from. So something happened down over here when I called split. I actually have a segmentation fault. Oh, that's not something I realized. So here, pause right now is a super duper large number because it's copying all the way up to the end, right? Because pause is currently going to be equal to end pause. That wasn't my expectation. And I can see here that my program actually kind of like stopped me at the area where my segmentation fault happened or where my exception was thrown. So this line over here shouldn't be pause minus substring start. It should be string.size minus substring start from the end, right? However many characters that are supposed to be copied from where I'm currently at, the substring start to the end. And again, this shouldn't be pause because that's way out of bounds. That should be substring start. So apparently I had a bug in there. And again, I didn't realize that until the debugger pointed it out to me. And then if we press play, again, we should see that if I split my string, kind of get this A, B, C, D thing. Again, if we set a breakpoint here and we throw it into the debugger, we should see that now if I step over, yes, I need to copy things over. I need to copy things over from position 13, which I think is out of bounds. If I wanted to see the string size, I could do string.size. And I don't know why when sometimes evaluating some of these expressions causes it to just like give some like exception, which is kind of weird. So this should be copying over the D at this point. If we look at our strings, we now have the D in there because we just added it, which is what I was intending to happen. But I'm not sure why the debugger over here just kind of like throws a fit when it hits the evaluation of the string size. Yeah. They're slightly different. Notice that this one has string.size. This one has pause. So slightly different, but more or less what this was like saying that this for loop says, like, you know, for each delimiter that you find, copy the contents of all the characters that appeared before the last delimiter, right? This one says copy everything that appeared after the last delimiter to the end of the string and add it in, right? If I took this piece of code out and we run our program, we're going to find that D won't show up in there. This D back here, he won't show up. We only get ABC. Because I've copied everything like up into like this last plus, but I haven't gotten anything to the end. So I need that little bit of extra code there to make sure that copy happens. So do you guys have any questions on how to use the debugger? Yeah. No, there's not a way. We'll eventually get to the Google test, which will show you how you can test your code in a bit more of an automated fashion. But you're still going to have to sometimes run the debugger on those test cases when things start going like funky to see like what is you want, like what's actually happening so that you can fix it. Yeah. Like when you're debugging, what do you mean by write code? Like you want to evaluate an expression and you just want to see what the result is? So there are a couple different ways. Like when you're inside the debugger, if you come down here and you press this little plus sign, you're then able to write an arbitrary expression. And that value will always be constantly displayed down here. You can also like highlight some expression, right click on it, and then say add to watches, and that value of that expression will show up down at the bottom. You can also just say evaluate expression if you only want to see it once. And again, this expression can be whatever that you want it to be. The other thing that can be useful sometimes is if you have a breakpoint and you right click on it, you can add some condition here. So maybe you have this loop and it runs like a whole bunch, like maybe it runs 1,000 times, but you know errors only start showing up on iteration 500 and beyond. So you can set a breakpoint here that says, oh, is I greater than or equal to 500? Then I'll stop here and I'll be allowed to look. And that breakpoint will only stop at this condition if it holds true. If it doesn't hold true, we won't stop there. The condition that you can write here can be any expression that you can write in C++. Can be placed here. The other thing that I should mention with conditions that can be useful if you know that a function is being called in different places, but only sometimes it goes wrong. If you know what the arguments are that make it go wrong, you can set a breakpoint like break inside this function if the arguments are x, y, z, and you'll stop there. Again, this call frame is also really useful because it shows you where the calls are coming from. Right now, split was called from main. So if I click back here, it shows me where was I calling split at. It was back here on line 14. So again, if you see that something's going wrong inside your function, it's not always your function that's wrong. You might be calling it with the wrong things. And so what you can do is you can kind of like go back up the call chain to see where were these values coming from if you got past bad values. Also can be useful for when you're debugging recursive programs because there's going to be multiple instances of your function called at once, as some of the older ones wait for the current ones to finish. So you can go back up here. Any other questions? Okay. Now we'll actually get into object-oriented programming. But if you come to office hours asking for help, you're going to have run the debugger yourself, have some idea of what is going wrong, and be able to explain that to me before I even bother looking at your code, because you need to learn how to fix your own code. It's not my job to do that. It's your job to make sure that your code's working correctly. So you're going to want to practice using the debugger. It's a very valuable tool, and it will save you a lot of time in the long run getting used to learning how to use it. Because it's a lot better than print statements, right? If you've done like print debugging where you put a print statement in to print out everything in your program to see the values, that's how I started. It's perfectly a good way, fine way of starting, because you're able to see what's going on. But like the bad thing is with that print debugging, you get to keep putting print statements in, and then you're like, oh great, I fixed my problem. Oh, I took them out. Oh shoot, something's still wrong. Put them back in again. Fix the new problem. Oh, right, take it out. Put more print statements in. Take more print statements out. If you saw back down here when I'm debugging, I'm able to see the values of the expressions for pretty much all of my local variables right away. And if I want to see something, I can add it to my watches down here, which saves a lot of time. I also don't have to keep taking things in and out, in and out. I've also had it where I've added print statements before in the past, and those print statements had bugs in them. Right? You might accidentally try to print your array at I, but I is out of bounds. Oh great, I added a new error into my program. Right? Hard to fix now. So the debugger, though, if you try to do something that's like out of bounds, the debugger's like, I can't do that. You're like, oh, well, okay, thanks for letting me know. But it's not going to crash your program. So classes. So first things for motivations. In real life, complex tools, items, and systems are made up of many parts. For example, a car, right? It has wheels, a chassis, an engine, a body, right? An oil filter. It has oil, it has gasoline. It has transmission fluid. It has like the gear change, right? There's a lot of individual parts, right? And if you had to think about like how all the parts of all the car came together to work at once, like no one would be able to work with cars, right? So we do a little bit of abstraction, right? We break it down into its components, right? Your phone has a battery, a screen, and a speaker, right? But each of those things is probably made up of other things, made up of other things, made up of other things, right? And so having this natural like way of looking at the world where we're able to see that things are made up of other things makes our life a lot easier with this abstraction. For example, you might want to play a game of Monopoly, right? A game has players, it has a board, it has properties, it has houses, it has spaces, right? A lot of different things make up the object, make up a game of Monopoly, which is surprisingly a very complex problem if you want to explain how to play it, even though 5-year-olds know how to play the game. Right? A person has an age, a name, a height, an ethnicity, right? A gender, and so on. So object-oriented languages are designed to help us implement these ideas, that things are indeed made up of other things, and to allow us to use that abstraction in our programming. So classes are the basis of object-oriented programming. How many of you guys covered this in 36A? Okay. A class is essentially a collection of data items that describe that idea, as well as methods that operate on that data. So you're able to collect the things that make up the object together, as well as provide methods that do stuff onto that object as a whole. Once we get into C, you'll see that a class is an improved version of a struct, as it allows us to have both the data and the methods together. With a struct, which is in C, you're only allowed to have the data items together, no methods defined on them. So if we want to define a class, you say syntax. The syntax is you say class, class name, then you give the description of the class. The description of the class are its data members, as well as the items that make as well as the items that make up that class. This is going to create a brand new type of whatever you cited, of whatever class name is. And this part right here is the blueprint of what the class looks like. And this is going to be your class declaration. So this stuff goes in your .h files so that everyone knows what this object looks like. Again, the class's declaration, I should say, should go to the .h file. And one thing that's really easy to forget if you're programming on your own is to forget this semicolon here at the end of this curly bracket. It needs to be there. If you're working inside C-line is smart enough to know to put it there for you automatically, so not much need to worry. But if you're working on your own, watch out. So over here, if we wanted to create a person class, we would just say class person, curly bracket, whatever makes up a person. If we're just trying to describe a line, class line, curly bracket, whatever makes up a line. Any questions here so far? So a class can have member variables. These are the things that make up the object. For example, if our person had a name, an age, and a weight, we would describe them as having a string for their name, an int for their age, an int for their weight, or again, maybe like a double for their weight if you wanted to have like half pounds or something. The types that you have over here can be any of the basic types like double, int, or float, but they can also be any other user-defined type that you create. They can be any of the standard library types as well. So there's no restrictions on the types that you can contain inside yourself. Any questions here? Okay, then we will jump straight into an example. Okay, well, I guess I need to make that one. Yeah. For the guards?
Yes, and we have like variables like that.
So again, like having variables inside the guards is different than having the guards. The guards themselves are not considered global variables. But if inside the guard in the header file you had like int x, x is now a global variable because it's not declared inside a function. A global variable is any variable not declared inside of a function or a class. So if you did int x, yes, yeah, it would be, because is it inside of a function? No. Is it inside of a class? No. Must be a global variable then. Again, even inside a namespace, there's still global variables inside that namespace. So again, if it's not inside of a class and it's not inside of a function, it has to be a global variable, right? If you have that global variable inside of a namespace, that global variable is a global variable inside that namespace. But it's still a global variable. No, it said no global variables. So what I want to do is make a new class. A complex number. How many of you guys have worked with complex numbers before? So a complex number is a number that's made up of two parts, a real part and an imaginary part. An imaginary part is, it's multiplied by the imaginary number I, where I is the square root of -1. So what I want us to do is I want us to create a class that's going to represent a complex number, and we'll define some methods on it in a little bit. But the first thing that I want to do is define the data members after my project finishes loading. So over here, I'm going to right click and say new. Okay, it's finally done. So right click over here, say new. I want a new C++ class. The name of my class is going to be complex number. And then I'm going to say OK. All this is going to do is it's going to create a CPP file for me and a header file for me. So my header file has my misspelled complex number in it. So maybe we'll undo this. And if you only want a header only, you can also say for that as well. So again, CLion already threw down the class complex number, the curly brackets, and the semicolon. We then have to define what our data member should be. So we said that a complex number is made up of what two things? A real part and an imaginary part. What should we use to represent the real part? We could use an integer, but probably a double, right, real. And we also have the imaginary number, right, the imaginary part, called maybe imag. So great, we've now declared a class that has two parts, the real part and the imaginary part. Any questions here? Okay. So this is a part that always tends to get people. So do make sure that you ask questions, and we'll get to, we'll definitely do some examples of it. So a class's constructor specifies how that class should be created. So when I go to create an instance of a person or a complex number or a car or a game of Monopoly, how should it be created? And when you call the constructor, right, you pass in the arguments to be able to build it. You've seen examples of this before with like the string, right? You can say like, oh, I just want the empty string, right? You give no arguments. Or I want a string that's a copy of another string. You pass in that other string. Or I want, a string that's some character repeated some number of times. Pass in the string, the character, and the repetition. Yeah. So all the declarations of the class's members will be in the header files, and they're going to be a part of the class. The definitions are still going to go in the CPP file. So the syntax for declaring a constructor is the name of the class. It's going to go inside the class itself, and then whatever parameters you need to build yourself up. When you also can do it as class names, parameters. So this is the declaration. The definition is class name. Again, the parameters, it matches the declaration. colon initializer list, which you'll see in a minute, and then there's some other piece of code that needs to be run. The initializer list is the part where you initialize the member variables. They can be either initialized to some default value that makes sense, or it makes sense for them to be initialized in some way from the arguments that you provided. This other code that needs to be run is more complex stuff. If you're not able to just say like, member variable equals argument or member variable equals X, anything more complicated than that, that's what goes into the body. If you're just saying like X equals Y, that stuff goes in the initializer list. And you'll see an example of that in one moment. The members that you initialize in the initializer list should be in the same order that they're declared. If you don't do it in the same order, they're going to complain. So for us, we have to initialize real first and then imaginary. If we initialize imaginary, then real, the compiler is going to complain at us. The initializer list is optional, and it looks like member variable, parenthesis, whatever value you want it to be initialized from inside the parentheses. So you're doing a constructor call here. There can be multiple constructors for your class if it makes sense for it to be created in different ways. And then if your constructor only takes a single parameter, you have to put the keyword explicit in front of the constructor if you don't want variables of that single argument's type to be convertible to your class's type. If you want to use an instance of the constructor, it's class name, arguments, and then to create a variable of that name, you've already seen it before, like std : string. My string is the letter Z repeated 3 times, right? You've seen that before already. But now you just say your class's name. So what things do we need to make a complex number? What makes sense to pass it so it can be initialized? A real part and an imaginary part, right? So we say the name of our class, complex number, and then we pass in real and then an imaginary, right? This right now is saying the only way that we can construct a complex number is if you give me both the real part and the imaginary part, which could make sense, right? Would you want to be able to create an imaginary any other way besides having to explicitly specify both the real part and the imaginary part? So what happens if I just say like complex number num? Right now I can't do that because in order to create a complex number, it always has to have a real part and an imaginary part provided. But if I didn't provide a real and an imaginary part, what would make sense for those values to be? Yeah. Or maybe just make them both 0 or something, right? Like maybe if you don't give me a value, you probably want it to be 0. That's generally the most likely cause. So if we want a constructor that takes no arguments, we would say complex number and then no arguments. And now I can create a complex number with no values, right? Another way that we might also potentially want to be able to create a complex number is a complex number where only the real part is specified for whatever reason. This would be complex number double real. Right, so now we're able to create it 3 different ways. No arguments, 2 arguments, the real and the imaginary both specified, and only the real part specified. Yeah. So the order that you put the constructors and the members can be in any order. So it's really like my personal preference to put the constructors at the top so that you know how to build the thing. So to go generate the definition, I'm going to hold Alt and then press Enter on mine and say generate definition for constructor, complex number. So now over here is where our initializer list is. And so we have to say our member should be initialized to the argument that we're passed in. So I'm going to say real, real. And this looks kind of weird, and I'm not sure if you can quite see this, but this guy right here on my screen is a little bit purple, and this guy over here is completely black. I'm not sure if you can see that or if it comes across well. So this real right here, it's not talking about this argument. It's actually talking about my member variable, real. This real over here is talking about the argument real. And if you're like, damn, that's confusing, I'm never going to remember which one is which, you can rename it. And you can say, you know, real start. And now you can be like, oh, well, my real value starts at real start. But one of my conventions is to name the names of the arguments the same things as the corresponding member variables. So if you're comfortable with that, go ahead and do it. And then we'd also say imaginary has the same value as imaginary. And do we need to do anything else to initialize our object? Yeah, probably not. Right? So I'm not going to have anything in my body because this will initialize the real member with the real start that was passed in, and it will initialize my imaginary member with the imaginary value that was passed in. Yeah. The only shortcuts that kind of exist in CLion, again, not across the entire world, is run, or not run, a code, and you can say generate, and you can say, well, I would like you to generate a constructor, and you can select what member variables you want, and it will go build that constructor where it just did it like I did. No. You got to be explicit about it being initialized. Right? So over here, it would be potentially possible to do something like this, like real is equal to real start. But again, if you're saying like, my member variable is initialized to the argument, that's the stuff that should be done in the initializer list. It should not be done inside the body of the constructor. The reason for this is a couple reasons. One is some of your argument or some of your members have to be initialized inside the initializer list. They can't be initialized later on. So what I should say is after you've reached this curly bracket here and you're inside the body, your class has already been created and all of its member variables have been initialized to something. Right? So all the members have been created. This part right here after the colon and up to the curly bracket is where the members are being created and being initialized to the values that you said to put into them. Right? But after the curly bracket, your class exists and all of its members have been defined. So if, for example, if you had a member field that you declared as const, it would have to be done up here in the initializer list because the only time you can define a value for a const variable is when you declare. You can say like const int x equals 5, right? But after that line, you can't change x to be anything else, right? Const int x equals 5, right? After that line of code, I can't change the value of x. So if I try to do this like const int x equals 5, it's going to be like, no, you can't do that, right? You've already made x and you've already initialized it. So if one of my member variables was const, it absolutely has to be done in the initializer list because once I've reached the body, it's already been created. I already have that real member created. Other things that have to be initialized in the initializer list are references because, again, when you create a reference, it has to be assigned to something. So it also has to be done in the initializer list. There are also going to be some of your member variables that don't have default constructors, right? That can't be created with no arguments. So if I did something like this, right, I kind of just got rid of this first guy here. I've already created and initialized real, but I've called this default constructor. So I probably just said like real equals 0, and then I said real equals real start. That's extra work, right? To initialize it twice. Once to set its value up here by calling the default constructor. Because, oops. What just happened? Because again, like this is the same thing as doing this. Right? Make it start with having no value if I left it off. And it's probably going to default to 0. And then I reassign it to be the real value. It's much more efficient to create and initialize simultaneously than to create and then initialize afterwards. So it'll be faster to do it this way, especially for more complex classes. And again, sometimes not all of your member variables have default constructors, and so you wouldn't be able to do this. So not all member variables have this one that takes no arguments. For example, if we didn't define this, we wouldn't be able to be constructed by just saying complex number x. It would be illegal because we wouldn't have defined this member or this constructor. Does this make sense? Yeah. You can use optional parameters for constructors. Completely valid. You could do it all in one, but I want to show you breaking it apart into different ones. So yes, we could do something like double real start equals 0, double imaginary equals 0, and then not have to define these two. But you'll see in a second that these two will be really easy to create once we have the first one. Control Z. Yeah. Or Command Z if you're on Mac. I'm going to go back and put this back in like it should be. The other thing that might be a little bit confusing if you did this, imag equals imag. When I'm talking about imag inside here, this guy right here is hiding my actual member variable because they happen to have the same name. So I'm saying argument equals argument. I didn't actually set my imaginary number. If you do happen to have this like kind of like conflict where you have a argument that has the exact same name as one of your members, the way that you can specify your member, you can do it in two different ways. You can say complex number : imaginary equals imag to specify that it's the complex number or the imaginary variable inside of complex number. Or there's a this, which is a pointer to yourself. This arrow imaginary equals imaginary. Either one of these two would work if you needed to be very explicit that I'm talking about my member variable and there happens to be an argument or another local variable with the exact same name. Or again, you could just make sure that they don't share the same name. But again, we don't need any of this code that's inside of here, so I'm going to get rid of it. For building my other constructors, one thing that you can do is called a delegating constructor. And so what you can say is, instead of running my constructor, go run this other one instead. So to do that, I'm going to say, oh, I want to go run complex number, but I want to call it with 0, 0. Thanks. So what's happening right now is when we run this constructor, what it actually does is it'll run the top constructor with the values 0 passed in for real start and the value 0 passed in for imaginary. If you're doing a delegating constructor like this, it has to be done inside the initializer list. If I do this, what this does is it creates a brand new complex number who has the value 0, 0. I don't assign it to any variable, so then I immediately throw it away. I would not be initializing myself to be 0, 0. So be careful about that. And then finally, for the last one, for our real, again, we'll do another delegating constructor. We'll call complex number with real, and then we'll call it with 0 for the second one. Again, as was stated earlier, we could have used optional parameters to only have to write one in this particular example. Are there questions about constructors? Because this seemed to confuse people a lot last quarter. Yeah. For like this particular example, I don't really have anything that makes sense to put in here. But like if we wanted to like you could do like print statements inside of them, like print out something happened. Or sometimes some of your objects or like your initialization has to be a bit more complicated. Like perhaps you're trying to initialize your object from a file, like the file contains representation. So you'd have to like open up the file and then read in the member variables one at a time to be initialized. That would be something that has to be done in the body. If you have to do like some for loop or something that's required to get things set up, that has to be done in the body. But if basically it's anything more than x equals y, has to be done inside the body. And again, like these guys over here for their initialization values, they could be the result of a function call. So we could throw like a function call in here to make it be initialized to be whatever that function returns. Any other questions? Okay, if you get confused later on, it's perfectly okay to ask about it. So some things to note is if you don't provide a constructor, a few default constructors will automatically be created for you. The default constructor, again, this is the one that doesn't take any arguments. All members will be created by calling their default constructor, the parentheses with no values inside of it. Also, a copy constructor for you will automatically be created. It'll take a const reference to another class and simply copies over each member variable. which we'll create this one in 1 second. If you want to be a bit more explicit about the fact that the compiler is providing these constructors, you can say, this constructor equals default, and it will do the default stuff that I said over here. Or if we want to make like a default copy constructor, we could say class name, const class name reference, or like original equals default. If for whatever reason you don't want these functions to exist and you want to be really explicit about them not being created by the compiler, you can say equals delete and the compiler will not create them. And sometimes for certain classes, it doesn't make sense to make the class copyable. For example, you've already seen examples of this with the streams. Streams aren't copyable. So they've actually made it explicit that their copy constructor is indeed deleted. So we'll make a copy constructor right now. So again, the syntax for declaring a copy constructor would be complex number, const complex number reference original. And so if we're going to do this one ourselves, are you going to? Okay. For whatever reason, the autocomplete's not working there. One thing to also note is that every time it made one of these functions declared outside of the class, notice it's complex number : : inside the complex number class, there is a constructor that takes 2 arguments. Inside the complex number class, there is a constructor that takes no arguments. Inside the complex number class, there is a constructor that takes 1 argument. So in a lot of ways, when you declare a new class, it kind of creates its own namespace for that class. So declaring the copy constructor, complex number : complex number const reference original. And so if you want to access a member of the class, it's a dot. So I might say like my real value is equal to the original's real value, and my imaginary value is equal to the original's imaginary value. So this just makes a copy of the original. So I pass in a complex number, and this will allow me to create a copy of that complex number. If you find the code that you're writing for your copy constructor is this, it's just make each member an exact copy of the other member. Instead of writing it here in the body, you could just say like equals default, and it will do the exact same thing. And you won't have to write it. Yeah. The purpose of a copy constructor is to allow you to copy your object, right? So when you do something like this, right? Right now I'm calling the constructor for the string that takes in a C string as an argument. When I do this, right, I'm trying to make a copy of name. So I'm calling the copy constructor. Make clone a copy of name. So if I want to be able to do that with my complex numbers, right, which for this to stop complaining, we'll talk about what public means in a second. If I'm over here in main and I want to now be able to use my complex numbers, I have to include complex number.h. So I might have a complex number num1. It was like 3, 4i, or 3 plus 4i. And then if I want a complex number num2, who's a copy of num1, that's how I specify it. Right? If I don't have that copy constructor, I can't do this because I haven't defined what it means to create a copy of the object. So assignment would work since the copy constructor is created. One other default member that's also provided is a operator equals for doing assignment. So that member is also created for you as well by the compiler implicitly. And so what that one does for operator equals, it just says, for each element in the class, make the left-hand side's member equal to the right-hand side's member. No, so again, like the copy constructor will automatically be created for you by the compiler unless you say don't. There are also some other things that would make it so that you couldn't create a copy of your class where the compiler wouldn't build that default copy constructor. That would be an instance where one of your member variables is not copyable. So if one of your subcomponents isn't copyable, the compiler won't generate it because it doesn't know what to do. But you could still define what it means to make a copy of your object later on. So yes, by default, the constructor or the compiler already made this function for me, right? I'm just being very explicit about showing like what's going on, so that you know what to do. Generally, you would write a copy constructor that's not just equals default when the class is more complex on what it means to make a copy of it. But one of the nice things here about C++ that I really like about it over Python is that I know exactly what a copy means, right? Have you ever had like the issue in Python where you meant to go create a copy of something, but you didn't really get a copy of it? Like, if you do this, and I'll let you go in like 1 minute. If I have like a list is equal to 1, 2, 3, and then I have like A is equal to L, and then I do something like A at 2 is equal to 5, and then I look at L, oh, L changed, right? But I meant to get a copy of it. In C++, I know exactly what a copy means because I'm writing the copy constructor, right? Unlike Python, when you get a copy of something that's a little bit wishy-washy what it exactly means. I will see you in class on Wednesday.